Welcome to 6.1 Properties of Exponents. Today we're going to take a look at how to use properties of exponents to multiply and divide monomials. We're going to use expressions written in scientific notation, and we're going to have some new vocabulary such as standard notation and scientific notation. Alright, so starting off with product of powers. For any real number a in integers m and n, if we have a to the m times a to the n, if you're multiplying similar bases, then that means you can add exponents. So a to the m times a to the n will become a to the m plus n. So an example, 4 squared times 4 to the 9th would be 4 to the 11th. B cubed times b to the 5th is b to the 8th. Now, the reason why that works as it does, b cubed means it's actually b times b times b, 3 times. B to the 5th then means it's b times b times b times b times b, 5 times. And since it's b to the 3rd times b to the 5th, if we put all those together, that means there's 3 plus 5, or 8 b's total, hence b to the 8th. Now, if multiplying means you're going to add your exponents, then that means division must mean you're going to subtract your exponents. So for any real number, a not equal to 0, and any integers m and n, if we have a to the m divided by a to the n, that's actually going to be equivalent to a to the m minus n. So a couple examples, 5 cubed divided by 5 is 5 to the 3 minus 1, or 5 squared. X to the 7th divided by x cubed is x to the 7 minus 3, or x to the 4th. Negative exponents. For any real number, a not equal to 0, and any integer n, if we have a to the negative n, a negative exponent does not make the answer negative. A negative exponent takes that value and it moves it to the denominator. So, for example, a to the negative n would be 1 over a to the n. Notice it is not negative. It puts it in the bottom of the fraction. If it's already in the bottom of the fraction, then it moves to the top. So 1 over a to the negative n becomes just simply a to the n. So for example, 2 to the negative 3rd would be 1 over 2 cubed, and 1 over b to the negative 8 would be just simply b to the 8. It does not make it negative. That's the common mistake. A few more. Here's the properties of our powers. Suppose a and b are real numbers and m and n are integers, then the following properties hold true. First, the power of a power. If you have a to the m to the n, so a power to a power, this means you're going to multiply. So a to the m to the n is actually equal to a to the m times n. So a squared all cubed would be a to the 6th. Power of a product. If you have a times b and all of that raised to the nth power, that's the equivalent of a to the m, b to the n. And finally, power of a quotient. If you have a over b all to the n, that's the same thing as saying a to the n over b to the n. Now, a special case here with this power of a quotient, if that exponent is in fact negative, remember what a negative does. It takes the thing on the top and it puts it on the bottom of the fraction. And if it's already on the bottom of the fraction, it then takes it to the top. So what a negative exponent is going to do in this case is it's going to move the a to the bottom and then the b to the top. So if you have a over b all to the negative nth, that's equivalent to b over a all to the nth, or b to the n over a to the n. So let's give some a try here. First one, we have negative 2a cubed b times negative 5a b to the 4th. So I'm multiplying here. When I multiply, I kind of want to do this like I did when I was adding and subtracting like terms. Same idea. They have to be similar bases in order to put these together. So first thing I'm going to take a look at are my values. And we're going to have negative 2 times negative 5, which is going to give us 10. Next thing I'm going to look at are my a's. So we have a cubed times a. No exponent written here, but if there's not an exponent written, that means it has to be 1. So when I multiply these together, a cubed times a to the 1st, multiplying means you're really adding. There's 3a's here, there's 1a here. 3 plus 1 means there's 4 a's total. And then finally, b to the first, b to the fourth is going to end up with b to the 1 plus 4, or b to the 5. And that is our final answer. Alright, same type of thing. A few more terms. Looks like they threw in some negatives at us, but it's still the same idea. So let's approach this one at a time. So again, we're going to start off with my values. We'll multiply the numbers together first. So we'll go 3 times negative 2, which is going to give me a negative 6. I'm then going to find all my a's. So I have an a to the 5th. I have a to the negative 4th. Now I'm multiplying. So the first property we learned still holds, and that is when you multiply similar bases, you're going to add your exponents. So this is going to become an a. 5 plus negative 4 means this is a to the first. And I put the 1 here just so you can see it as a to the first, but remember, if it's a power of 1, you don't necessarily need to write it. Next thing I have in line here is a c to the negative 2. I don't have any other c's, so I'm just going to go ahead and write this as c to the negative 2. Just bring that down. And then I have one more term left, which is b cubed. And that's going to go right here on the end, b cubed. Now, last thing to do is to go through, look at this, and clean it up any way that I possibly can. And the one thing that I can clean up is this here, it's still a negative exponent. And remember where negative exponents belong. Negative exponents belong on the bottom. So if I clean all this up, we have a negative 6. We have an a to the first. We have a b cubed. And then we have a c to the negative 2nd, which means that entire thing is going to go to the bottom of my fraction. C squared goes down there, and that is going to be my final answer. Negative 6ab cubed over c squared. Alright, here looks like we have some division. S squared divided by s to the 10, and remember, when you have division, that actually means subtraction. So 2 minus 10 is simply going to give me negative 8. S to the negative 8, when it's negative, it means it's actually on the bottom of the fraction, and that leaves this as 1 over s to the 8, which should make a lot of sense, because here it's saying you have 2 s's on the top, you have 10 on the bottom. If you have 2 on the top and 10 on the bottom and you cancel out, that's going to leave 8 left over on the bottom. Alright, let's simplify. Negative 3 c squared d to the 5th all to the 3rd. Here, all of this is being raised to the 3rd power, which means I have to take each one of these and raise it to the 3rd power. So we're going to take negative 3, and we're going to raise that one to the 3rd. And then we're going to take c squared, and we're going to raise that one to the 3rd. And then we're going to take d to the 5th, and we're going to raise that one to the 3rd. And we're going to see what we end up from each one. So we'll start with negative 3 to the 3rd. Negative 3 to the 3rd, if I put this in, this is negative 3 times negative 3 times negative 3, which is going to give me a negative 27. C squared, that's a 2. C squared, all to the 3rd, is your power to a power. Power to a power means you're going to multiply. So 2 times 3 is going to give me a 6. So c to the 6. And then d to the 5th, all cubed. Power to a power, you're going to multiply one more time. This is going to end up as d to the 15th. And there's your final answer. Negative 27, c to the 6th, d to the 15th. We'll give one more try here. Negative 2a over b squared all to the 5th. Again, much like the last one, since everything's being raised to the 5th power, I have to take that 5th power and I have to say we have to raise everything to that 5th power. So negative 2 to the 5th, we have a to the 5th, and we're going to have b squared to the 5th. Yes, that is a B. Apologize again for this writing. Using my mouse today, not going the best. Negative 2 to the 5th, going to give us negative 32 when you type it in. a to the 5th, b squared to the 5th. Power to a power means you multiply, so that's going to leave me with b to the 10th. There's our final answer. Alright, last problem. Why do these properties of exponents come into play? Why do they help us? Well, they help us a lot with scientific notation. Scientific notation is used for really, 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 really big numbers and then really, 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 really small numbers. So to give you a refresher on what scientific notation is, you're going to have some value, some number, in between 1 and 10, and that number is then going to be multiplied times 10 to some given power. That number that's being multiplied by will tell you how many times to move the decimal place. If that exponent is a positive number, you're going to move the decimal place to the right and the number is going to become very big. If that exponent's a negative number, you're going to move that decimal point to the left and that number is going to become very small. So for instance, 3.6 times 10 to the 5th means I start at 3.6. I then take the decimal point and I'm going to move it 5 times to the right. So 1, 2, 3, 4, 5. Every time you move the decimal place, you fill in with a 0. So 3.6 times 10 to the 10th can actually be represented as 360,000. Now, how does that help us, or how does the properties of exponents help us deal with scientific notation? Well, 360,000 is a big number, but there's even bigger numbers than that. Think about the distance between us and the moon, us and the sun. They're huge numbers. I don't want to work with that many zeros. I want to simplify things. Scientific notation is a way to take very large numbers, very small numbers, and simplify them. So for instance, in biology, a petri dish started with 3.6 times 10 to the 5th, or 360,000 germs in it. Half an hour later, there's now 7.2 times 10 to the 7th. That's a lot of germs. I want to know how many times as great is the amount a half hour later. So to figure out how many times greater this number is, I'm simply going to take the number I'm at and divide by the number that I'm currently starting at. So the number that I'm at would be 7.2 times 10 to the 7th. Now I took the x out and I just used the dot there. Same type of idea. And I'm going to divide by the original amount, which is 3.6 times 10 to the 5th. Reason why I don't like the x so much, we're used to seeing that x as a variable, so I kind of try to stay away from the dot, or away from the x. So the dot is good. Parentheses, excellent also. Just something a little bit different so we don't confuse that with an x. Now what's nice about multiplication is this is commutative, meaning you don't have to go in a certain order. You can multiply anything together that you want as long as it's all multiplication. For instance, 2 times 3 is the same thing as 3 times 2. They're both 6. And division really is multiplication. So I don't have to do this multiplication first. I can technically do this division first, which is actually what I think I'm going to do, because 7.2 divided by 3.6 is 2. Now I look at this and I say, okay, 10 to the 7th divided by 10 to the 5th. Well, that's the properties that I just learned. So that means that's going to be 10 to the 7 minus 5, or 10 squared. So this is simply left with 2 times 10 to the 2nd. Scientific notation tells me I should take my decimal place, which is currently right there after the 2, move it 2 spots to the right, fill them in with zeros, which means a half an hour later, the number of germs in this petri dish is 200 times the amount that I initially started with. That's a lot. And on that note, I'm going to go wash my hands because that's a lot of germs. So complete the self-check quiz. Bring your questions tomorrow to class. We'll answer them and we'll take a look at a few more of these problems. Have a great night.